Alright guys, this is the review for the retest, graphing quadratics in Vertex form. If you have not tried to do this without the video, please go attempt it without the video, check your answers, and then come back to the video if you need help. That's a good way to tell whether or not you understand the material. When I'm looking at quadratics in vertex form, remember that the reason it's called vertex form is you can see the vertex. So I'm looking at this quadratic right here, and I see that the vertex is -3, -4. That's my vertex. I'm going to write that on the vertex line, and I'm also going to put that in the middle of the table. So -3, -4. I'm going to take this moment to fill out the rest of the x values in my table. Remember that the x's in the table are read from top to bottom, which means that the smallest number should be on top and the largest number should be on the bottom. A number that is smaller than -3 is -4. Smaller than -4 is -5, and smaller than -5 is -6. Larger than -3 is -2, then -1, and 0. And so your x value should look exactly like that. The vertex is at -3, -1, 2, 3, 4 right here. That's my vertex. There's a line that goes through that vertex. It is the axis of symmetry. And it's the line about which the graph is symmetric. We talked about that today in class. My axis of symmetry for this is x equals -3. It is always that first number from the vertex. So if you've identified the vertex correctly, you have your axis of symmetry. This parabola is going up, which I know because there is no negative in front of it. There's a is positive. The multiplier in front is positive. So my direction here is up. And what I'm going to do is I'm going to graph the rest of the points on this parabola and see if I can get the rest of this information from those points. You can use a graphing calculator to do this, but I'm going to use my pattern. You can score bonus points on the test by writing out the pattern correctly. You get 2 points per correct pattern. But like I said, you are always welcome to use a calculator, and you're going to get all of the points that you can earn on this question if you use the calculator. The pattern for any parabola starts as out 1, up 1, out 2, up 4, out 3, up 9. And this parabola follows that pattern because we don't have an a value. I mean, our a value is 1, but it's not 2 or 1/2. So we haven't changed the multiplier. So it follows this pattern. You always move from your vertex. So from my vertex, I go out 1 and up 1. And I do that in both directions. And I go out 2 and up 4. And again, that's something we do in both directions. And then out 3 and up 9, which is here. And we do that in both directions again. And the reason we do that is that we want our parabola to be symmetric about this line right here. It's not a parabola until you've connected those dots and put arrows on the end. So here's my parabola. And then from this graph, I can get the rest of the information I need. My points for the table, I start here at -3, -4. And if I go out 1, that's -2 and -4. The y value at those points is -3. It's up 1 from -4 right there. And if I go out 2 and up 4, I'm right here at a y value of 0. So it's -1 and -5. Those y values are 0. And if I go out 3 and up 9, I have a y value of +5. And that is those x values at 0 and -6. The reason we put the vertex in the middle is that then we can see the symmetry in the table as well. See how it goes 5, 0, -3, -4, then -3, 0, 5. It's symmetric about the vertex. And that's why we put the vertex in the middle, is that then we can see the symmetry that we see on the graph in the table as well. Zeros are where it touches or crosses the x-axis, and that happens here at -1 and -5. Remember that those are points, so it's -1, 0, and -5, 0. Y-intercept is where it crosses the y-axis, and that happens right here at 5. And that is also a point. It's the point 0, 5. The domain of all parabolas is negative infinity to infinity, and they're both in parentheses. The negative infinity has to come first. You cannot put it second, so it must look exactly like this. Your range is from -4 to infinity because it's a facing up parabola. And then the transformations, that's how has it changed from the parent function, which is y equals x squared. And so the answer to that is that it moved left 3 and down 4. It moved left 3 and down 4. Take a moment to pause and make sure that all of your answers look exactly like mine. There is a way that we write things in mathematics, and you want to make sure that your vertex looks exactly like my vertex. Your axis of symmetry is x equals -3, exactly like mine. Please make sure that you haven't left off a set of parentheses or forgotten negative anywhere, because those things matter. All right, let's look at the next problem. It's problem 2. Again, the first thing I'm going to do is identify the vertex. So I look to the equation right here, and my vertex is +1, -3, because remember, when you pull it out of the parentheses, it changes signs. I'm going to go ahead and put that in the middle of my table, because that's where it belongs. We'll go ahead and label it. Okay, +1, -1, 2, 3. That's my vertex. My axis of symmetry goes through the vertex, and that's the line x equals 1. It's always the same number as the x value from your vertex. The direction for this parabola, I look to the a value, and in this case a is 3, but it's positive, so we're going to go up. And to get the rest of the information, I'm going to go ahead and follow my pattern and graph the rest of my points. So here, my pattern is out 1, up 3 times 1, because of this 3 right here. Out 2, up 3 times 4. Out 3, up 3 times 9. And so we're going up 3, up 12, and up 27. And you don't have to graph the 27, right? But it's important for us to know that that's what's happening there. The reason that we're going up 3, 12, and 27 and not 1, 4, and 9 is because a is equal to 3, so we have to multiply our up values by that 3. So if I go out 1 and up 1, 2, 3, out 1 and up 3, out 2 and up 12, that puts me at +9. Out 2 and up 12 is +9. And then that last set of points, like I said, is not on our graph, so we don't have to graph it. That's our parabola. It's really skinny. And so what we can do is we can use these points to fill in our table, and then to talk about the rest of the things that are going on over here. So remember that we read tables top to bottom, so I want my smallest x value on top. What is smaller than 1? 0. Smaller than 0, -1. Smaller than -1, -2. Larger than 1 is 2, 3, and 4. And that's the way your table should look. And your table should look exactly like that. If it's in the other order, then it's wrong. All right. If I go out 1 and up 3 to get to these points, my point is at x equals 0, my point at x equals 2. I'm at y equals 0. And then the next set of points out to where I get to x equals 3 and x equals -1. And those y values are 9. And the last set, and again, you can use a calculator to give you the table and give you this information, but the last set is up 27 from the vertex. So if I start at -3 and go up 27, I will be at y equals 24, and that's my last set of points. And again, you can see the symmetry in the table. And that's why we like to put the vertex in the middle of the table. The zeros are where it touches or crosses the x-axis, and that happens at 0, 0 and 2, 0. Y-intercept is where it crosses the y-axis, and that happens right here at 0, 0. Domain of any parabola is negative infinity to infinity. And the range, because this parabola is facing up, we start at the vertex and go to infinity. So that's -3 to infinity. The transformations of this parabola, we go in order as we see them. So this is a vertical stretch of 3. We move right 1 and down 3. Those are 3 transformations. All right, let's move on to question 3. Right here. And again, the first thing we do for any of these problems is we identify the vertex. And so here's my vertex right here. It's -3, -1. And I'm going to put that right in the middle of my table and label it. I'll go ahead and fill in my x values. This should be -4, -5, -6, and this should be -2, -1, and 0. My vertex is at -3, -1 right here, and my axis of symmetry goes through the vertex. So it's x equals -3. Forgot to close my parenthesis, guys. Don't do that. Now, I have noticed that there's a negative out here in front of my equation. And that means that instead of opening up, we're going to open down. And what that means is that the pattern I will follow is going to be out 1, down 1, out 2, down 4, out 3, down 9. And so we're going to graph those points. So from here, I'm going to go out 1 and down 1, out 2, down 4, which puts me right here at -5, out 2, down 4, right there at -5. And then out 3 and down 9, which puts me down here at -10. Right there. So this parabola opens downward, like that. We're going to go ahead and fill in the table here. So my first set of points, the -4 and the -2, we've moved down 1 from -1, which means we're at -2. My second set of points here at -5 and -1 is at -5. And my third set of points at 0 and at -6 are at -10 in terms of y values. And again, you can see that symmetry in the table, which is what we want to see. Zeros are where it touches or crosses the x-axis. This does not touch or cross the x-axis, and so what we say is none. You could also say NA, or it doesn't have any. And then y-intercept is where it crosses the y-axis, and so that happens here at 0, -10. Domain of any parabola is -infinity to infinity. And the range of this parabola, because it's negative, is from -infinity to -1, like that. Transformations, we write them in the order we see them. This is a reflection over the x-axis. It has moved left 3 and down 1. Left 3 and down 1. Again, take a moment to pause and make sure that your information looks exactly like mine, that you have a parenthesis on this infinity and that you have a bracket on that -1. All right, that your y-intercept is a point, the point 0, -10. Make sure that your table starts with -6 and ends with 0. So make sure that your information is the same as mine, exactly the same. All right, let's talk about the jump of a grasshopper, which is modeled by this function. And remember that what we're looking at is actually the jump of the grasshopper. And since this is in vertex form, the vertex of that parabolic jump is right there at 525. So the grasshopper's maximum height is 25, because that's my y value for my vertex. And the grasshopper's distance, well, to get to that vertex, the grasshopper went 5 inches. So to get all the way to the end of his jump, he's going to have to go another 5 inches. So the grasshopper's jump is 10 inches long. All right, pogo stick, which is the last problem, works exactly the same way as the grasshopper. So we're talking about hopping up in the air on a pogo stick, and again, the vertex is the very top point, so it's 516. What's the maximum height of the jump in inches? Well, that's your y coordinate, so it's 16. And how long was the jump? Well, again, we had to go 5 inches to get to the vertex, which means we have to go another 5 inches to land, so we're at 10 inches. And then they ask, what's a reasonable domain and range for the jump? Well, domain, we left the ground when we were at 0 inches, and we hit the ground when we were at 10. And range, if we're on the ground, we're at 0 inches. And if we're at the very tip top of the jump, we're at 16 inches. So that's a reasonable domain and range right there. Again, we just take the maximum value from here, and then we get this how long by multiplying your coordinate from your vertex by 2. All right, guys, if you watched this whole video all on your own, put a nice big star next to your name on the front so that I will know when you turn in your review sheet, when you take your retest, that you watched the entire video. That you made sure all of your answers look exactly like mine.